This, so today and Friday we'll review. I don't know if we're not going to finish today, so we'll finish Friday. Okay, get as far as we can. 7.1, expect identities using Pythagorean, even and odd, reciprocal, and quotient. And of course, as we move forward, like those might be needed no matter what, right? They keep coming up over and over again. All right, so prove the following. All right, your exam questions will most likely come from your homework. Maybe some that I did in class, okay? So if you did your homework and it made sense, you should be good. So I'm gonna choose the left-hand side because it looks more complicated and I see a bunch of squares, so maybe I can use some identities, right? Trying to turn something simple into something complicated is harder than going from complex to simple. So let's start right here. So I'm going to distribute cosecant. That'll give us cosecant squared plus cosecant times sine, both squared. Now, what is the reciprocal of cosecant? You remember? Yeah, so these two are going to cancel, right? So just make a note here. 1 over sine squared is secant squared. Using the reciprocal identity. So at that point, these cancel. So I'm left with cosecant squared x plus 1. You remember what cosecant squared x plus 1 is equal to? All right, from the Pythagorean formulas. No, this is cotangent. Cosecant squared x plus 1 is equal to cotan squared. Yeah.
So it doesn't matter if it's, let's say, cosecant squared x minus 1 or it could be plus 1, either way it's cotan.
Is it minus 1 in the formulas?
Yeah, the formula is minus.
Let me see. It has to be the same. So either I wrote the question wrong. Let me check the question. Cosecant. Yeah, it should be cosecant squared minus 1, right? question I wrote down was in here. Oh yeah, check it out. It's prove or disprove. I didn't read that. So right here. It would show it's not equal to. Because of this. So +1 should be a -1 here. So since -1 is equal to cot10, then this is obviously not going to happen. So this is false. But on the exam, I'm going to give you stuff that is true. I'm not going to try to mess with your head. It will be true, and you need to show it's true. Okay. Like I don't like. I think it's annoying when you're not sure if it's false or not. Anyway, so 7-1 will have stuff like this, but it will be true. Okay. 7-2. Was the sum and difference. Identities. So you'll have a couple like problem solving type, and then again, prove this. Okay. So number 2, question 2. Given that sine alpha is equal to 2/3 and cosine beta is equal to -1/4, with alpha between pi/2 to pi, and same thing for beta, pi/2 to pi. So what quadrant is that? The pi/2 to pi is quadrant 2, right? So that means that if both are in quadrant 2, sine will be positive and both cosines will be negative. Okay, so let's call this alpha and this guy beta. 2 different triangles. Using this guy, opposite over hypotenuse. I'm going to skip the step for Pythagorean. This is square root of 5. Okay. But since it's in quadrant 2, this should be negative. Adjacent over hypotenuse. This will be 15 positive because it's related to sine. So what I forgot to write the question down, I'm sorry. What they want is this. So once you have this, just use the formula and that's it. Just plug in the stuff that we need. Over here, I'm going to write down everything that we need. We were given sine alpha. Cosine alpha would simply be adjacent over hypotenuse. We were given cosine beta, which is sine would be this guy. Cosine beta was -4th. All right. Anyway, it's all here in the triangle, right? So sine alpha plus beta in the formula. I don't have that memorized. Let me look it up here. That will be sine alpha cosine beta plus cosine alpha sine beta. Let me make some space. That will be equal to 2/3 times -4th plus -√5 over 3 times √15 over 4. Is that straightforward? Is that okay? So now cosine alpha minus beta, that's going to be cosine alpha cosine beta plus sine alpha sine beta plug in the numbers and we're done. I'm gonna let you simplify it on your own just to save time here. Okay. Any questions on what we just did on number 2? So they have to tell you or give you a hint. So right here, they said alpha is within pi√2 to pi. So that means it starts at the top part, 90 degrees, and goes all the way to 180. So this is telling you the location. So if you look at the circle, where's that damn thing? Pi/2 is right here. So from here to here is what it's saying, pi/2 to pi. So you're in this slice. Okay, so quadrant 2. All right. Any other questions on 7.2, number 2? All right, let's do a proof next. This one simplifies, but who cares? I'm just killing time here. Are you good on this page?
Why do they plus greater than 75?
It shouldn't be. It should be negative. It should be minus. Okay. Minus minus should be positive. All right. Zero proof. This is still a 7.2. Prove the following. That cosine x plus y times cosine x minus y is equal to cosine squared cosine x squared minus sine y squared. So if you start on the left side, we will have to use sum and difference of angles. If you start on this side, you're going to have to try to do some factoring or sum to products, that type of stuff. I think on number 3, both sides are about equal. I don't see one easier than the other. I'm going to start with the left, just because that's what 7.2 was about. It's about sum and differences. Only reason, but I think it's the same. So in an exam, you have all of chapter 7 available, so you can use whatever you want and on any question, right? But on 7.2, we only had that method. So you would have to start on the left, but now that we have all those other ones, you could start over here. Does that make sense? Okay. All right, so I'm gonna start right here. Try to be as neat as possible. So use the sum of cosine from your formula sheet. That's gonna be cosine x, cosine, let me see, cosine y minus sine x sine y. So I changed this first part. Now do it again for the difference. So that's going to be cosine x cosine y plus sine x sine y. Is that okay? So right here I did sum and difference. I'll make a note for you. The identity for sum and difference of angles. But this one, all we can do is multiply stuff out. We got this times this and this times that. Okay, just multiply everything. No matter what, it's going to be annoying. So cosine x times cosine y, you notice how those are the same, so that'll just be a square. Cosine x cosine y squared. Cosine x cosine y times sine x sine y. So it'll be plus. Right, so just multiply them together. They don't combine any further because they're completely different. Now do the next terms. Negative sine x sine y times both of these. Notice how this is the same, right? Running out of space. You read that? Real kind of small. So sine x sine y times cosine y. So this is sine x sine y right here. Cosine x cosine y. These are the same. So you'll get minus sine x sine y squared. All right. So in hindsight, I just realized that that was a difference of squares, so we didn't have to do all this. We could just jump straight to the difference, right? But if you chose to FOIL it out and you didn't notice, you would get all these terms, and the middle will cancel because these are the same. So we should have just jumped straight to here. A squared minus b squared. But I'm tired and I missed it. Does that make sense? You see how this is a plus b, or a minus b and a plus b? So you could have jumped straight to here. So the middle step is unnecessary. Go ahead and square this nonsense though. We're trying to get to where? So whenever you're confused or not sure what to do next, look at where you're trying to go and let that guide you. So I know I need a cosine squared, right? I don't have a cosine y, do I? So I'm gonna substitute this with something else. I have no sine squared in the results. So I'm gonna change these two because I already have these two. I need those two. You see what I mean? So I'm not gonna mess with this because I need those. So right here, I'm gonna change the cosine into 1 minus sine y, sine squared y. And I'm gonna change the x guy over here into 1 minus cosine. Does that make sense? Does that logic make sense to you? Okay. So I changed this dude right there. And this one. We did Pythagorean right here. We did it twice. So at this point, I'm gonna multiply stuff out and hope something cancels and leaves me only with what I'm trying to get to. If it doesn't work out, then I should try something else. And life sucks. Distribute, we'll get these two terms. Right? This has a minus, so whatever comes out of this multiplication will have to have its signs swapped. So sine y times a 1. Cosine times sine, that'll be this here. Yeah, I know this is kind of long, so you guys still with me up to that point? Any steps that were strange or confusing? Don't feel bad if you got lost on step 1. It's fine. Just let me know. Because that's the point of today. It's ask questions because exam's coming. Ignore that. Okay. So distribute the sign then. So this will be minus sine squared plus cosine squared x sine squared y. So the signs swap right there. So notice they're gonna cancel, right? Just like we wanted. These are gone. So as we wanted to show, all this garbage is equal to the right-hand side. So this is a proof using the sum and difference of angles. Okay. Any questions on number 3? Is that okay? All right. I'm gonna turn the page. You guys cool on this page? One more time. All right. We'll move on to 7.3 then. All right. Oh, yes.
How did you get it to the after you were on the same the next?
Here?
Yeah, after that.
Okay, so from this line to that line, you multiply cosine squared times the 1, which gave me cosine, right? Cosine squared times this negative sign will be this. So they don't really combine, so they're just multiplied, right? Then over here, we had a minus, so I put a bracket because I didn't want to deal with the minus right away. So sine squared times the 1 gave me this. So I'm distributing from the other direction. It's the same, right? It just might look kind of weird. Sine squared times this guy gave me this term. Does that make sense?
Yeah.
And then just distribute the sign and stuff cancels. Okay. 7.3 is about double angle. And a half angle. So let me give you a problem solving type and then we'll do a proof type. Okay. So number 4, given that sine x is equal to negative 12/13 and x, it's going to straight up and tell you, is in quadrant 3. Okay. I'm going to want you to find sine f of x over 2, cosine x over 2, sine 2x, cosine 2x. I'm not going to ask about any of the tangent stuff. I know it came up in the homework, but I'm not going to ask for double tangent angle or tan 2x or tan half. Okay. It will not be on the test, but it is in your homework. So before you start, you need to figure out cosine, right? Because these all require cosine. But also you need to figure out which quadrant is the half angle in. Because if you don't know, then you won't choose the correct sign. Okay, so that's I don't usually like to deduct points for sign errors, but here it's different and it matters. So don't, you need to know where the sign's at. So what you should do is remember quadrant 3 means, right? From pi to 3 pi over 2, correct? That is quadrant 3. Right, I'm gonna put quadrant 3 right there. So if that's where X is located, the angle X, the half angle would be half the interval. Does that make sense? To divide everything by 2. Now we're no longer in quadrant 3, right? Where is this? Which quadrant is this? Here. Yeah, it's gonna be quadrant 2. Okay, so this will tell me what signs to choose when we're doing our work. So we gotta keep referring to this. Okay. So we're gonna have to build a triangle based on this information. Opposite, hypotenuse, and this is one of those magical triangles. It's a 5, 12, 13 triangle. If you want to solve for this side, go ahead. You're gonna get 5. Okay, but this is for X, right? Based on angle X. X is in which quadrant? Right, regular X. It's gonna be 3, right? Is X and Y positive or negative here? We need to be able to spot that. Yeah, both are negative, right? So we have the negative Y, which came from the negative sign, right? Sine is negative in quadrant 3. So is cosine. So is the X value. So put negative and negative. Okay. Now we can start, at least almost. So we have the negative sine and negative cosine, right? I'm just gonna write that there for now. This is all my side thinking here. Now let's start. But are there any questions on these ideas? Does that make sense? Like where all this is coming from, the signs? Okay, well, sine x over 2. That is equal to plus or minus the square root of 1 minus cosine x over 2. Which sign am I choosing? Plus or minus for the half angle? This is dependent on the location of x over 2. So an x over 2 is sine positive or negative? Positive, right? So we choose the plus. Okay, so we're going to get 1 minus negative 5/13. That makes sense? So we chose this sign, and then we had that sign chosen too. And then we're good. I mean, technically that's our answer. I'm gonna skip the simplification to save some space. That would be 1 plus 5/13, the double negative divided by 2. That would be what? 18/26, which reduces a little more, but I don't care. Any questions on part A? Is it okay? Okay. Now cosine, plus or minus. Which one do we choose? So we go to quadrant, so remember, it's wherever the half angle is located. Quadrant 2 is x is negative, right? Yeah, you're right. Okay. So this will become negative 1 minus 5/13 over 2. So this will become negative 13 minus 5, 826. Anyway. Any questions on A or B? That okay? Okay, well, sine 2x is equal to 2 sine cosine. Here we don't have to worry about plus or minus, just plug in the sine and cosine. So the double angle is a little easier to deal with. So this will become 2 times sine times cosine. Whatever the hell that is, I don't know. Some number. Is there any questions on part C? Right. Cosine double angle has 3 different forms. Use whatever you want. It will be the same in the end. I'm going to use this one just because it's the only one I remember. Okay, just plug in cosine and the sine and then square them, and that's it. And you'll be good. So 5/13 squared minus 12/13 squared. 25. 13 squared is at 169, right? I feel like that's right. I don't know. Anyway. Any questions on number 4?
Can we give like the exact value?
What's up? You want the exact value?
Like, can we, like on the test, can we do it? Like.
Well, exact would be simplifying this, right?
Yeah, but like if it's like, I don't.
You talking about the decimal?
Yeah, that's.
It should be exact. I mean, I'm not gonna be upset if you don't reduce 100%, but I don't want to see decimals everywhere. Okay. So I'll most likely put in the question the exact solution. So remember, exact means something like this, right? And yeah, non-exact would be an approximation, which is what your calculator would give you. But if you stopped here, it'd be cool. That's fine. Any other questions on B, C, or D? All right. Okay. Let's do one more, I guess. Well, you know what? Maybe we could do 2. That sucks. Okay. You guys cool on that page? Or not? Okay. Just let me know. Prove the following, that sine 3x is equal to 3 sine 3 sine x cosine squared x minus sine cubed x. This is still 7.3. On this one, I think, well, that 3, this 3 throws me off. So it makes me not want to start on the right-hand side. Also, we are in a double and half angle section, so this is probably the way to go. I don't know how to deal with that 3. Like if we were to start on the right, I would have to get very creative. And that feels like work, so I'm gonna start over here. So I chose 3x because I know I can rewrite that as a 2x plus 1x. That's the idea. Because we have that formula from 7.2, right? The sum of angles. And then we also have double angle formulas in this section. So we can combine ideas from 7.2 and 7.3 to help us out here. Okay. So this will become right, make this your alpha and beta. Formula says sine 2x cosine x plus cosine 2x sine x. So this is the sum and difference identity. Okay. So now I see a bunch of double angles, which might help us, right? So use the double for 2, sine 2x. We know that's going to be 2 sine cosine times cosine plus. Again, I'm going to use this form for double angles, cosine. Right? So this guy is these two. This is this one. We use the double angle. You guys still with me to that point? So at this point, I'm seeing that I have a 2 there. So maybe I'm heading the right direction. Let's multiply stuff out and see if I can get a 3. Okay. This becomes 2 sine cosine squared. Just multiply that guy in there. This is a product, not a distribution. Over here, we got to distribute on 2 terms. This will be cosine squared x sine minus sine cubed. You guys still with me? So notice I have the same thing right here, right? Same type of terms. So 2 plus 1 more gives me that 3 I wanted. It's just written backwards, but you agree that 2 times 3 is the same as 3 times 2, right? Same deal. Still 6. So 2 plus 1 is 3. There we go. That's what we wanted to show. Is there any questions on number 5? Right here?
Yes.
Just multiply this guy, because technically this is 2 times sine times cosine times cosine. So The only two that really combine is cosine, cosine. It gives me the square. So these are still being multiplied, but these simplified into a square. Any other questions on 5? You guys have any homework questions you're struggling with? Because I'm gonna stop here for review. I've extended your homework 7.3, 7.4, and 7.5. Okay, I'm not opening 1 and 2 anymore. Those were extended a couple of times already. We're off Monday, right? So Wednesday is your test. Friday, we'll finish the review. If you want to stay and do problems, let me know. If not, I'll see you later.